So today we are going to practice kinetic energy and potential energy from chapter number 6 of physics IGCSE. So here is first of all kinetic energy, and its formula is 1 over 2 multiplied by mass, velocity and square. Now potential energy's formula is also written in the book of the physics, which is change in GPE weight multiplied by change in height. It means potential energy's formula is, in short form, is mgh, which represents mass, gravitational energy and height. Then there is an example of these energies, and this you will tell that which formula you're going to use. There is also another formula, which is kinetic energy is equal to potential energy. You will need to know it by yourself which formula are we going to use in the question. If we're saying that athlete has a mass of 50 kg, mass is 50 kg. The best way is to write what you know and what you don't know. For example, we know mass. Let's see what we don't know and what we know. Anything else? The foot of the hill is 400 meters. So thing which is in meters is always the height, distance. So we will write it as a height or distance which is equal to 400 meter, and it is above the sea level as said in the example 6.2. The summit is 1200 meters above the sea level. Now this was the above the sea level, the foothill, and this is 1200 meters above sea level. The question is, by how much does the athlete's GPE increase? Assume that acceleration due to gravity is 10 meter per square. So what we know is this, and what we don't know is GPE. How much GPE is increased by these levels. So first and of all, we are given two heights, two areas, like 2 meters. So if we have to find the kinetic energy's formula is potential energy's formula is mgh. We don't have h. Actually we have, but we have 2, so we are confused at which value are we going to use in the question to find our gravitational potential energy. So write the formula first. Then it is mass. We are given mass 50 kg, and gravitational energy is always 10 multiplied by height. You have to find the height. We are confused at which one are we going to use. So this was summit sea level and this was the foothills level. What we're going to do, we're going to subtract it from these both values, and what we'll get 800 meters. So we have 800 meters. Now we are going to do a kinetic energy, and its formula is 1 over 2 mass multiplied by velocity. Let's do some of the examples related to kinetic energy. As written in the book of physics IGCSE, the van of mass 2000 kg is traveling at 10 meter per square. The best way is to write what you know and what you don't know. It may get easier for you to solve your answer. So 2000 kg is our mass, and the velocity as written here is 10 meter per second. Now, what we have to find, there are two parts. We have to calculate its kinetic energy. So let's do it first. To find it, we have to write the formula first, which is 1 over 2 mv square. Then put values according to the formula. Our mass is 2000 and our velocity is 10 meter per square. Let's add them or solve them. So basically this is also multiplying here. Now what we get after multiplying this, and the most important thing that we always forget, that is to take the square of the velocity present in the formula of kinetic energy. It is very important to do because it is a part of the formula of it. So after multiplying and solving these all the values, we get this value, and this is joules, the unit of energy. The kinetic energy and potential energy both are always in joules, and this is our kinetic energy. Now what is the second part? The second part is this: its speed increased to 20 meter per second. By how much does its kinetic energy increase? Now the speed is increased to 20 meter second. Write the formula again. What we do after this, add the values again. 4000, this will be our increase. This is our different. Now we are going to subtract it from the previous one. This will be our increase in kinetic energy. Quite very easy work, and yeah, let's do some more examples of it. also graph here of the kinetic energy, which can also become in the Cambridge exams when you will appear. I am going to appear in 2025, and I have almost very less years to do practice of it, but we'll do. In the following examples, is the object's GP increasing or remaining constant? This can be the MCQ of it. It claimed that Superman can jump 200 meters vertically upwards. 200 meters we have. Now, its mass is 100 kg. By how much does GPE increase? Write the formula of GPE. Now, write the formula. What is mass? Mass is 100. This is 10. And the height is 200. After multiplying these values, after solving this question, we will get after, so it looks like this. The values are 100 multiply by 10 multiply by 200, as it is shown like the is equal to, we get this value, and in kilojoules it will be like 200 approximately. Yes, this is our GP, and it is also joules. So moving to the next question, which is a raindrop weights. The weight is, as written here, 1 multiplied by 10 raised to power minus 6 Newton. The weight and force is always in Newton, so we will consider it as a weight or force. Its GPE 0.8 joules when it falls from a cloud. The high was the cloud. How high was the cloud? Mass find करेंगे. We find the mass. Mass is 0.01 multiplied by 10 is g, and height is, we have to find the height, but we have our gravitational potential energy already given. What we'll do, we will solve this value and the h will remain here, the height will remain here. So let's solve this value. 0.01 multiplied by 10, which is approximately in points in decimal form 0.1, So 0.1 is our mass multiplied by gram gravitational energy. Now height will remain here because we have to find it. Now 0.8 divided by 0.1, it is multiplying it with here, but here it will be derived from the gravitational potential energy, and the answer after dividing them both would be our height. 0.1 is equal to 0.8. Sorry, 8 is our height.